COVID, I used to get rockets. You know rockets?
Yes.
And you are chatting with someone and then you start splitting them. So when COVID came and we started putting on the masks, I improved. I could teach, everything is dusted, but I never got rockets. So now when I got flu, I remember that the mask was helping out, at least when I'm running the wall. So yesterday we were able to look at a couple of flip-flops, and then we ended on the other set, and then we had an adjustment from the by making the R equal to not set, and then we just looking for the where I put the notes. We are about finished, so don't worry. So where we will stop today is where the test will end. But we can agree where you want we can agree where you want the Savona. Yesterday Savannah, sorry, you dodged my lecture. And where is your friend? He also didn't attend. I will. You don't need to explain anything. He will explain himself when he comes. He had told me that he has issues of sorts, so I don't want you to split his issues here when you have no permission from him. We have gone as far as making sure that we put a pulse into the flip-flop by labeling the clock, C, with the set, and then here being able to get the complementary outputs, the Q and the not Q, or Q bar. We went up to a delta latch, and for the delta latch when we had to make the R equal to S bar. And now let's look at the age-triggered flip-flops. The one thing I want to tell you about electronics is that people who discover a few things or who come up with some stuff try to make it sound like it is so special. So your phone, Apple will have the way it calls things, Android will call things their own way. I think Tesla, Elon is producing his own smartphone, he will call it a couple of apps his way, just to make sure that they sound as if they are different from their own. So you will find, and also that goes with the compatibility. Remember, you have a C cable for charging or transferring data, then you have, I don't know how they call this other cable, and then you have the one of iPhone. I don't believe in these special things. From the time I flew business class by accident, I didn't find anything special there. Well, it is special. The chair can become a bed, the metal has wine and whatever you want. But you won't fly in the same thing. If it got a problem, all of you get a problem at the same time. And you learn at the same time. You cannot say in business class, carry me. The plane will leave the same time and land the same time. So whether you are carrying an iPhone, you take a photo, maybe it may look so, but it will still be you. If you are not looking good, you still make it good. And it also depends on the user. I've seen people with probably nice music either at home or in the vehicle, but because they don't know any settings, they still listen to as if it is just a studio local radio. But everything is good, but they don't know how to choose the settings. Even computers. computer, you find somebody with a nice laptop, but they don't know how to choose the resolution of the screen, how to get the apps which are needed for it. You find like there are people who carry this phone, and all they do is just to say yes and no. Especially these, I don't know what to call them, rich people or happy, lucky people. You find a daughter in UK sends a nice phone, and all they know is to say yes and no, and then they keep there. They don't know that they can get an app and they measure their temperature or pressure. They can know their pace while moving around their gardens. All they know is yes and no. So that's what I wanted. So when you see a word age triggered, you're like, that sounds so much. So the flip-flop changes state. This flip-flop changes state. The outcome is what we are calling the state all around. Only at the rising, because that's what we are calling the edge. So this is our pulse. The square wave. This is a rising edge. This is a falling edge. And this is another rising, falling, etc. So this flip-flop changes state or the output only at the rising edge. Only at the rising edge. Rising edges are these positive edges. Positive edges or falling edge. Or falling edge, that is negative. Negative. So it's already, the output will already change when it is at this point, these points here, and these points, when it is rising and falling. There is a JK flip-flop. I'm summarizing so that we finish, and when you want to master electronics, you do some electronics and instrumentation next semester. And if you want to go further, then you really go into, now that you know the basics, you can go along and read more, practice more. Electronics is handy. You can fix your stuff. At least you can check out what's wrong with your stuff and only take it to a technician when you know what it should be putting in. Because you can't put it in, but when you know. The computer of my vehicle got spoiled. I slept on the road with it. A guy came, fixed it, but it didn't work out well. It will still show me the heating element of the vehicle as an error. And they had told me that it is 800K, a new one. So 800K, I said I'll be using slow, I'll be using it when it is stable. When it is not stable, I leave it. So recently, to got a problem again, I went to another guy. I ended up getting this whole set at 250K. What I'm trying to tell you is that when you go to the technician, when you don't know what is going on, they will do anything. While another vehicle of mine, some time back, when I went to the, I got a drawdown of the battery, and when I went and charged the battery and put it on, the block broke 1888. this whole stuff, the cloth, everything leaked. Each LCD, each component of the LCD data. So I went to the guy at the petrol station where I used to do service. The guy went on the dashboard, removed everything, brought out the circuit, and went on the other side. And like he's doing something, came back, put back, did what we call troubleshooting, like removed the corners of the battery, and then the clock now started with 1 AM or 1 PM, whatever it is. When they showed these 2 zeros and 4. And I gave him, I think I gave him 5,000. I didn't take it personal. So I went and packed again, and I think it was a weekend or some small holiday. The battery went down, I went and charged and brought it, the same thing happened. So when the same thing happened, I removed the terminals, and then when I put back, it stabilized. I hated that guy. I went and told him, never touch my vehicle again. I teach electronics, but because I don't want to spoil other parts of the car, I don't know, but you wouldn't belittle me to this extent. That you remove the whole, circuit board, you walk on the other side where I know that you don't have a soldering gun or anything, you come back and fix it, you troubleshoot, and then you take my money and also make me look stupid. So I made sure that he does not touch my vehicle every time I go there. I think after COVID, I no longer see him these days, but he knows it. I hate him. Okay, maybe I say I dislike him. Hating is too heavy. and people, technicians will do that to you, because when they see ignorance in you, they will split your gadget. If it is a radio, they will open it completely, and split it there. When you come, it's like you are worried to never work again. And when they know there was no problem, they know that probably some contact was off, or even a wire for soldering, just. And when you come, you are worried. You say, what is the problem? So don't worry. Come after 3 days, I'll tell you what the problem is. And then when you come back, they say the ice blew in the dreaded circuit. You say, which one? Of course, you can't go to buy it. So you say, how much is that? 50K. Good, you give. Now, after giving 50K, the guy just solders the other wire, and then even when you come now, he adds labor. Says labor is 10K, 60K gone. But because it's now booming, the sound is good, you are like, thank God, now my thing works. I think in the holiday, one of the pots of my cooker couldn't work after I had opened to check something else. I left it. Now all of a sudden on reset, it just started working. I didn't do nothing. No, nothing, even shook the thing. Now it works perfectly. So electronics is like juju sometimes. You need to be patient, you need to give it time before you go to the technician. You can just try to check a few things. Troubleshooting means that you switch off. If it is a phone, remove the battery. Remove the cover if it is a removable battery. Remove the cover, remove the battery, charge again, switch on. If it persists, then you can go to even the computer. Do not say now it has crashed, no. Just remove the cable for the power, remove the battery, leave it there for some time, come and power it up and see whether something can come up. The jack flip-flops, this eliminates these terminologies. Once you Google them, they come as they are, and they are the same terminologies, whether in the UK, in the US, in China, or in other place. So it's not something like I cannot explain it in the context of our place. After all, the most electronics we use are state when we have the 111, the R of S equal to 1, by use of the flip-flops, the two flip-flops, by use two flip-flops as a master flip-flop, and slave. If I teach this thing again, I will not say this. And slave, it reminds us of bad days. When I went to Ghana, they took me to some fort, and I went into where they used to detour slaves. When you reach there, you even smell some flesh, some human flesh in the place. It was like a point of no return. And the building, they were building like the way they built this place. Big wall. That was, made me emotional somewhere. That someone can just tell us like that. Come on and say, this looks nice. Give me this one. Okay. This one, also this one. Looks there.
I mean, if we don't improve ourselves, we don't go to school, we don't do science, we are just praying every day.
We are back actually. We are back to those days, only that in the modern way. Because when you look at our debt option to our contribution option, we are doing badly. Some of you, I'm told, went to now opted to major in math because I'm giving over 9 practicals, 10 practicals. What kind of nonsense is that? When I'm in the lab there hustling from group to group, I'm not getting anything. I don't benefit anything. But I just want to see a Ugandan also talking sense and saying that I did an experiment. But someone chooses to opt to a major in math because it is stressful in physics. Personally, I will teach you from day one, and I'm proud that I'm left with only a few days to make it a reality. If you do not work hard for your own continent or country, which is impossible to make it country or country-wise, if you don't work on yourself, for yourself, you'll be a slave. I'm a slave of my stomach because I have to feed myself and teach you and get some money. But at least I have a voice. If I didn't want to work, I can stay home. And even if they sack me, I can get a job somewhere. This is not my first place to teach you. But if you don't have if you don't work hard and get the papers to be that confident, you'll just be begging. Please, anything they tell you to do, you will work. You will do it. So I will change these words. Maybe I'll get another word for master slave. But this is just to show you that one drives the other. One is dependent on the other. The circuit symbol is that we got the input J and K. The inputs J and K. And then we enable them in the clock. And then we still get out the two complementary options. The truth table has a few things which are you have tomorrow other than mine? Only mine. I'll make it simple, but white. So if there are there's nothing at J, nothing at K, and if the clock is not pulse, there's no pulse on the clock, then we can say we are beginning from there. If we haven't put any J, K, and we have a pulse, we can still say we are still at that point. Then we start our 0, 0, 0, 1, 1, 0. But then we look at the pulse when it is rising. So all of these when it is rising, I'm just drawing this pulse here. And so this one here, this is so I'm talking from here and here. Rising. So we have QN here, we have 0, we have 1, and then we have the terminal part. And this part here is the J. I think there is where I was supposed to say put the set on one of the truth tables. The truth table for the RS. The reset set flip-flop with the level. The 0, 1, that part we should have put there the set. We should have put the S. Finally, on this part of the flip-flops, we look at the toggle. Toggle, are you done here? Yes. Toggle. The toggle key means that it does the two things by pressing it again. So when you press it first, it gives you this. If you press it this, the next moment it changes what you have. So this is the toggle flip-flop. And toggle key, like on a PC, the caps lock and number lock are examples of toggle key. This changes state. This changes state on every rising edge. Every rising edge or falling edge. So I have a clock which is giving us a pulse. Make sure these things are vertical. Not vertical. Then I will just put these dotted lines to make sure that the output is relevant to the pulses on top. So the output Q will change whenever it is, so the change is on the rising or falling. So we have the changes going here, then here, circuit symbol. Symbol. please remind me of the came-up examples when we are doing tutorials, when we are revising when we are doing tutorials, probably before the test or after the test, whichever it is. Test is what? It's tomorrow, so I should explain it. We do examples now. When I do examples, you think they are coming. When I do examples, whatever I will do, you now start struggling to understand thinking they are coming. So we shall do examples when we shall do examples. But if there is a question, it will still be there. You are mature people, you are campus people, you are good for everything. You are, and then listen. For the toggle, you press the same key, the text becomes uppercase. You press the same keyboard key, then it becomes lowercase. You press the number key, numbers, that small part of the numbers activates. Some of you have not been interacting with the keyboards since when the phone came. I know you have a keyboard on your phone, but that keyboard is not the actual QWERTY keyboard, which is having a set of the main one, then the caps locks. It is just having even some of the keyboards you can backspace, but you can't delete the things on the right. You have to first tap here, then use this thing here on your phone instead of having a delete hand. Only those who have tablets that sometimes the whole keyboard comes up with the backspace and the delete option. The output is changing on the rising, and then only when it is rising, that's when you are having a change. So when this one was rising, you have a change. Then it is constant, it changes again when it is a rise. Or it can only do it when it is falling. So if it had started changing here at the falling, it will again change from the falling back. Because the pulse, this pulse here, you have the pulse rising here, then falling here, rising here, falling here, rising here, falling here. And that's what we meant is that the output will show a change when it is rising here, and then becomes constant until when it is rising again, then we have a change. And then it will change again when we are at the rising part. Or you have it changing at the falling part, and then it will be constant, changes again at the falling part, and then starts changing. So it depends on which one you choose, whether the rising edge or the falling edge of our clock. The clock is this pulse like for a square wave which we get from the generator. So from a function generator, you can get your sinusoidal wave, the sawtooth, or the pulse. Experiment 10 is well suited for that. Give you the pulse and then shows you how you can pump, clip, or get a frequency response once you feed that in a set of capacitors and resistor. Then we conclude this section with counters. Counters are clock sequential circuits. modulo n, or divide by m. Divide by m counter has m states. An n bit and n bit binary counter has n flip-flops and m equal to 2 to the power n states. So we have a 0, 1, 2, up to 2 to the power n minus 1, 0, 1, 2, it is. So some of you are like, I'm just summarizing, I can't write all the stuff about this, but once you Google, you get the stuff. Applications are relative. Is it relative? What I normally use an example of a knife. When a guy goes in the shop and there is a stall for knives and he's a madam, his way of looking at the knife is different. When a lady goes to the supermarket and is looking for knives, there are currently knives which are very sharp, like a razor. They have wooden handles, and they are strong. They don't bend easily. If you are careless and probably you are cutting the tomatoes and you slip up, you end up having your finger with as part of the menu. Now, if a lady is in the supermarket and she may not want to buy such a too sharp thing because she knows she's peeling I'm sorry when I say ladies and I say peeling, you say that does he think for us we are not just peel things. Some things you have to accept. They are done that way. I cannot breastfeed a kid, okay? Much as I would have wished. I got no push. You get a point? So some of the things you don't have to go in the clouds and you want to make them impossible just because you came to class. And there are things that you have to do because you can. Because you are tender, you are soft, you can easily make the kid feel comfortable. When I hold the kid, they feel I'm stiff and before they understand that I'm the dad who can give gifts, who will take them to school, they may not be as comfortable as when they were doing that with you as a baby. So you make sure that you look for more stuff in order for you to be able to understand, so that I can also finish. Then we have ripple counters. And these ripple counters, e.g., we can have a 4-bit binary ripple counter. We used to have, I think, a counter. The flip-flop is there for D14. But I think we also had counters sometime back, and then they got either spoiled or something. After all, they were supposed to be thrown away. We said that an n-bit binary counter has n flip-flops. So a 4-bit binary counter will have four flip-flops. So we draw the 4 flip-flops, which are this way. So I put the second one here, the third one here, and the fourth one here. And then we shall see how they are synchronized. They are synchronized with we have a clock pulse here, and this clock pulse here, it gives us to the Q, and then we have the Q bar, and then we can use this output in the clock here, and then we have the Q, and then we have the Q complementary here, and then we feed it in the part of the clock here, and then we have the Q, and then we have the Q bar here, and then we feed it into the clock part here, and then we get the output here, Q, and this output. So we have the Q naught here, then we have, which is the least significant bit. We have the Q1 here, then we have the Q2 here, and we have the Q3, which is the most significant bit. What is going on is that we have our pulse. So I'll start with the clock pulse. I don't know how many I should. The more I have, the better to understand what is going on. Let me stop here. It's a 4-bit. So Q naught will change this type of flip-flop. You have a change in the Q in the output here. The Q naught will change only when there is the rising of the clock. Okay? So that means when we are rising for this other Q naught, when we are rising, we change. No change until when we are rising again. Then no change until we are rising again. No change until when we are rising again. No change until when we are rising again. This is our Q naught. This is significant value. The output will get fast. Q1 is now when we change now for this, because Q1 is getting from this other the output of this one. So it is this one which will determine our change when it is rising and when it is only change when it is rising. So now we have this other Q1. It has no significant size. So it will change when this one was rising, and change again when it is rising. EDC. Do the same for these other ones, if you have enough space. So the next one will be, it will go up here, then again it will go down when it is rising here. Then go up when it is rising. EDC. So the whole process continues with it in itself. And so if you imagine if you had an 8-bit count, the whole process will take you some not century or whatever. It's I don't want to say it looks abstract. It's because we don't have a particular D14 would bring it out. If and then you look at the nature of the lighting and see how now they are responding, delaying this one, being now able to delay the lighting further than when they were lighting quickly when the pulse was low. I mean, they are for different values of the R and C. So I don't know how to get to this, but I can say read more on your own. The things I know are not all from the people who told me. I got an A in fine art and I never attended any lesson of fine art in A level. Not a single one. All the assignment things I was handing in, I had painted them in my vacation. Fortunately, the teacher who was teaching us in A level is the teacher who was brought when I qualified for that school. There was no fine art, but everyone knew in my primary that I was good at fine art. So they were wondering, what are you going to do? They knew the school I was going to go to. So they were like, what are you going to do with your talent? When I went to school, they brought 2 teachers in fine art, and fine art started flourishing. So I pushed fine art until A level. By A level, this guy knew that I'm exceptional. So when I would not dodge, but when I didn't attend his things, he understood I was doing PCM. Then fine art. I chose PCM fine art because I knew this one was not going to take my time. I would paint I would draw when I'm in the mood. Okay, when I'm in bad mood after the physics is harassing me and I can't read more, I have chopped the integration by inspection. I'm tired. Then the chemistry, they call them mechanisms. And we had a Varuga teacher who used to be Varuga when he's explaining mechanisms. When I'm tired of those, then I would draw something or do some fine art. So I didn't have I didn't attend a lesson in A level. Okay, so we have now an understanding of analog as where we have continuous signals during the analog TV broadcasting. We would get the transmitters from Morolo, and these transmitters would send the signals up in the sky, and using the ionosphere, we would be able to get the signals on our TVs by just connecting an antenna. So these dishes in Morolo would send the signal, and then when this signal would interact with the ionosphere would bounce back stuff to our radios, or maybe let me specifically say to our TVs. So our TV would be able to give us a signal, and you wouldn't care. If you were in the Busha, you would get a TV from Kenya and start watching. If you were at Katuna, you would get a Rwanda TV and start watching. If you were in Mule, you would be able to get South Sudan. I don't know where there was TV in South Sudan by then. So with analog, you would get an image and something which looks like what should be, and if you have adjusted properly, you get a nice image. And this image would come depending on how much came and passed, and if there was a tree, you would get another image which bounced off here. And if you, I don't know whether any one of you was able to see, where were you in 2012? Huh? P4. Because digital migration happened, I think, in 2012. That's when my 3 TVs became obsolete, because now I needed a decoder to use them. And then I was able to buy a small flat one, which now gave gave me signals free to air. From that time, I cannot pay for TV subscription. I don't have time to waste. I download whatever I want. Now, after digital migration, signals now, I think I explained it in during moon viewing. Now signals go straight to their location. They got the cell light, and once they got the cell light, the transporter of the service provider now accepts that you have paid subscription, immediately sends you a signal to the TV. And the signal is clear. That signal, you cannot get, doing analog, because of malpath, what they call malpath, or path. Because of malpath, you will see a presenter or anchor with many images, with the central one which is clear, but with some outlines around. And then when you got the antenna and start adjusting, you see them now becoming clear and maybe clearer. Now, if it is raining and it is having a thunderstorm, you see even your TV also being perturbed because the lightning is interfering with these beams. And those of you who will choose space science, you will be told that, or you will be told that at midnight, this layer here reduces because of it was enlarged by during the day. At midday you have sunlight duplicating more. You have the ozone being perturbed to the oxygen ions, and then these ions here are the ones you find they are more, and of course you lose an electron to become this positive. So those electrons and the positive ions are the ones which constitute an ions sphere around the Earth. So during the day at midday, there is this dissociation due to the enhanced by the UV. And then this layer enlarges. As it enlarges, it lowers down. When it lowers down, this distance shortens. At midnight, it subsides. And so when it subsides, the thing goes far away higher and reaches further distance. And I told you that during crossover, that during Champions League of those days, because Champions League matches are late in the night, you will see a clear picture. So we thought it was because it is at night, but it was actually because of science. Nowadays, when the image, when the signal is low, you see things just stuck like this on digital TV, or you see boxes around. You can't have a clear and not clear. It's either on or off, because we now deal with 1 and 0. So we were able to transit to digital, and so on Tuesday we shall be able to work on analog to digital conversion, and then once we have an analog, so if I speak, my microphone is speaking an audio signal, which is analog, is varying, pushing air, compressing air here and there, and then it will turn it into a digital stuff, put it on SD card, then I'll be able to watch it on the computer. I will even be able to upload it, and you'll be able to see it on the web when it is in digital form. And when you are watching my videos on Mwere, you use your phone to be able to now change this thing on Mwere and be able to listen it on your phone through the speaker or your headsets. So it has to be turned again from digital to analog. And we shall do this business on Tuesday. So I wish you good luck in tomorrow's test, which will come up here.
What is at the end of that test?
There? This one, eh?
No, the Q bar at the top, 4 bits. The last one.
This one it should have been another, if it was to give another, if we had another flip-flop, it would be an output to the clock part. To now be the one to be the pulse that is in place of the clock. But we are sticking like 4 pieces. We don't expect further now. Okay, so see you tomorrow. Any argument? Okay. The Wednesday group we are meeting in a few hours.